Good morning, grade 11 senior high school students of Cauayan City National High School. Welcome to General Mathematics. For today's video lesson, we will talk about one-to-one function. This will help you to assess your knowledge of the different mathematics concepts previously studied and your skills in performing mathematical problems. This knowledge and skills will help you understand one-to-one functions. As you go through this lesson, think of this important lesson: how one-to-one functions represent real-life situations. This video lesson, the learners are expected to demonstrate understanding of key concepts of inverse functions, exponential functions, and logarithm functions. Learners should also be able to concept of inverse functions, exponential functions, and logarithm functions to formulate and solve real-life situations with precision and accuracy. The objective of this video lesson is to represent real-life situations using one-to-one functions, determine the inverse function of a one-to-one function, represent an inverse function through its table of values and graph, find the domain and range of the inverse function. To start with, let's have the definition of a one-to-one function. A function f is a one-to-one function if it never takes the same value twice, or the f of x sub 1 is not equal to the f of x sub 2, whenever x sub 1 is not equal to x sub 2. That is, the same y value is never paired with two different values. Example, in our Venn diagram A, function f is a one-to-one since not two inputs have a common output. In our Venn diagram B, function f is not a one-to-one since the inputs -1 and 0 have the same output. On the other hand, the function g of x is equal to x squared is not a one-to-one function because g at -1 is equal to g at +1. Another example, there are a lot of real-life applications of a one-to-one function. Determine whether the given relation is a function. If it is a function, determine whether it is a one-to-one or not. Example number 1. The relation pairing an SSS member to his or her SSS number. Is it a function? Each SSS member is assigned a unique SSS number. Thus, this relation is a function. Further, two members cannot be assigned the same SSS number. Therefore, the function is a one-to-one. Example number 2. The relation pairing a citizenship to a person. Is it a function? The relation is a function because each person has a citizenship. However, a person can have two citizenship, dual citizenship. Therefore, it is not a one-to-one function. Let's proceed to the graph of a one-to-one function. If f is a one-to-one function, then no 2 points x sub 1 and y sub 1 and x sub 2 and y sub 2 have the same y value. Therefore, no horizontal line cuts the graph of the equation y is equal to f of x more than once. How to determine if the function is a one-to-one? A function f is a one-to-one if and only if the graph y is equal to f of x passes the horizontal line test. Horizontal line test. It is the test to check if a function is a one-to-one. A one-to-one function has only one value for each y value. If a horizontal line test passes through a graph more than once, the function can't be one-to-one. Okay, let's try to determine if the two graphs is a one-to-one or not. Let's try our first graph. I will draw a horizontal line test. That's it. For the second graph, I will draw another horizontal line test. Okay, so let's determine if the first graph is a one-to-one or not. The graph touches the horizontal line test how many times? Let's count. 1, 2, and 3. Again, If the graph touches the horizontal line test twice or more than, it is not a one-to-one function. Therefore, the first graph is not a one-to-one function. For our second graph, it touches the horizontal line test once, therefore, the graph is a one-to-one function. Determine whether each of the following situation is a one-to-one function. The relation of a dog to its family members. Is it a one-to-one? Since the dog is related to all the family members, therefore, it is not a one-to-one. The relation of a person to his or her passport. Is it a one-to-one? A certain passport can only belong to a certain person, therefore, it is a one-to-one. A car model to its manufacturer company. A manufacturer produces thousands of cars for a certain model, therefore, it is not a one-to-one. We have learned that the function can be regarded as taking an input x and processing it in the same way to produce a single output f of x. This time, we will find another function that will start at f of x and process it to produce x again, and that is the inverse of a function. Let's define first what is an inverse function. It is a function with a domain B and a range A, given that the original function has a domain A and range B. It is denoted by f inverse. It is defined by the equation f inverse of y is equal to x if and only if f of x is equal to y for any y in range B. Since both are functions, then a function has to be one-to-one for its inverse to be function at the same time. It is a many-to-one function. Its inverse is one-to-many, which is not a function. To find the inverse of a one-to-one function, there are three steps. Number 1, express the function in the form of y is equal to f of x. Number 2, interchange the x and y variables in the equation. And number 3, solve for the y in terms of x. Okay, let's try to solve the inverse of g of x is equal to negative 5x plus 1. Let's apply the first step, that is to write the function in the form of y is equal to f of x, and that is y is equal to negative 5x plus 1. Second step, we will interchange x and y. Y becomes x and x becomes y plus 1. The third step is to solve for the value of y. We will transpose positive 1 to the other side of the equation. That becomes x plus 1. Oh, sorry. That should be x minus 1 is equal to negative 5y. Okay, for us to have the value of y, we will now divide both sides of the equation by negative 5. Negative 5. Okay, cancel negative 5 in the numerator and negative 5 in our denominator. And then we will now have y, that is x minus 1 all over negative 5. We will change y into the inverse notation, that is, what is a function? G of x. Its inverse is g of inverse of x is equal to x minus 1 all over negative 5. That is the answer. Next is find the inverse of a rational function, that is the h of x is equal to 4x plus 8 all over x minus 3. Let's apply the first step, that is to write the function to the form of y is equal to f of x, and that is y is equal to 4x plus 8 all over x minus 3. And then we will interchange y and x. Y becomes x is equal to 4. Our x here becomes y plus 8 all over. Our x here becomes y minus 3. We know that x has imaginary denominator of 1. Okay? So we will cross multiply it. X multiplied to y minus 3 is xy minus 3x is equal to 1 multiplied to 4y plus 8 is 4y plus 8. We will combine values that have y, that is xy minus 4y is equal to 3x plus 8. Okay, so let's factor y in our xy minus 4y. That is y is equal to x minus 4 is equal to 3x plus 8. We will divide both sides of our equation by x minus 4 to have the value of y. Cancel the numerator x minus 4 and the denominator x minus 4. And then we now have the value of y, that is 3x plus 8 all over x minus 4. And then we will change the y to the inverse of the function, and that is h inverse of x is equal to 3x plus 8 all over x minus 4. Another problem, find the inverse of the rational function h of x is equal to negative 2 all over x plus 2. First step, write the function to y is equal to f of x, that is y is equal to negative 2 all over x plus 2. And then interchange y and x. Y becomes x is equal to, okay, negative 2 all over x becomes y plus 2. Okay, we know that x has a denominator of, imaginary denominator of 1. We will cross multiply it. Okay, x multiplied to y plus 2 gives you xy plus 2x. 1 multiplied to negative 2 is equal to negative 2. Alright, so combine terms. Okay, so we just have a value of x and y is equal to a positive 2x becomes to negative 2x and negative 2. Alright, let's continue it here. So for us to have the value of y, we will divide both sides of our equation by x. We will cancel numerator x, denominator x. Okay, then we have the value of y, that is negative 2x minus 2 all over x. And then we will change the inverse of our function, and that is h inverse of x is equal to negative 2x minus 2 all over x. Okay, another, let's find the inverse of the rational function r of x is equal to 4x all over 5 minus 4. Before we proceed with our solution, let's simplify first our function by applying our last topic, that is simplifying rational expression. That is 4x minus 4. Okay, 4x all over 5 minus 4. Okay, its LCD is 5 and 1. Why 1? 4 has imaginary 1 as its denominator. Okay, so 4x all over 5 multiply to 5 multiply to 1 will give us 4x. And then minus 4 multiplied to 5 multiplied to 1 will give us 20. All over the LCD, that is 5. Alright. So we now have our new function, that is not a new, it is still our function, that is 4x minus 20 all over 5. Alright, so applying the first step, okay, we will change the function in the form of y is equal to f of x, and that is y is equal to 4x minus 20 all over 5. And then interchange y and x, our second step. That is y becomes x, and then x becomes y minus 20 all over 5. We know that x has an imaginary denominator of 1. We will cross multiply it. So x multiplied to 5 is 5x, and then 1 multiplied to 4y minus 20 is still 4y minus 20. Alright, let's have the value of y by transposing negative 20 to the other side of the equation. It will give us 5x plus 20 is equal to 4y. For us to have the value of y, we will divide both sides of our equation by 4. Cancel for the numerator, cancel for the denominator, and we will now have the value of y, that is 5x plus 20 all over 4. And we will change the inverse function of Rx of our y, that is R inverse of x is equal to 5x plus 20 all over 4, and that is our final answer. Okay, let's have another topic to find the domain and range of a one-to-one function. Okay, so let's find the domain and range of the function f of x is equal to ordered pairs of 1 and 17, 2 and 11, 3 and 5, 4 and negative 1, and 5 and negative 7, and its inverse. So let's find first what is the given domain and range of the given function. F of x is equal to the set of 1 and 17, 2 and 11, 3 and 5, 4 and negative 1, 5 and negative 7. Negative 7. Ayan. Plus. Alright. So let's find its domain. We know that in our ordered pair, we know that the first value is x, 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 x. So that is our domain. Alright, so 1, 2, 3, 4, and 5. As easy as that. Okay, so our range, we know that in our ordered pair, this is our y, 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 and y. Okay, so we have 17, 11, 5, negative 1, and negative 7. Okay, so that is the domain and range of our ordered pair of our function f of x, of our original function f of x. Okay, so let's find what is the inverse of our function. Okay, the inverse of our function is just the inverse of our ordered pair, and that is the set of 17 and 1, 11 and 2, 5 and 3, negative 1 and 4, and then the last is negative 7 and 5. Okay, so let's find its domain. The domain of the inverse functions is 17, 11, 5, negative 1, and negative 7. And the range of our inverse functions is the set of 1, 2, 3, 4, and 5. So that is the domain and range of the two functions. Alright? Let's have another example. That is, find the inverse of the function f of x is equal to 5 minus 9x. Then, draw the graph in one Cartesian plane. The inverse of the function is function of x inverse is equal to 5 minus x all over 9. To start our solution, let's have a table of values. And we will set our x into values of negative 2, negative 1, 0, positive 1, and positive 2. Okay, let's have our function that is 5 minus 9x. Okay, so at x is equal to negative 2, our function becomes 5 minus 9x. 9 negative 2 multiplied to negative 2, and that becomes 5 minus 18 plus 18, sorry, because negative 9 multiplied to negative 2 will give us positive 18, and it will become 5 plus 18 becomes 23. Alright, so next, at x is equal to negative 1, our function becomes 5 minus 9 multiplied to negative 1. Okay, and then that becomes 5. Negative 9 multiplied to negative 1 will give us positive 9, and 5 plus 9 is equal to 13. I'm sorry, that is 14. Alright. Okay, so next. Okay, 5 minus 9 at 0 is equal to 5 minus negative 9 multiplied to 0 is 0. It will give us a value of 5. Okay, next, 5 minus 9 multiplied to 1. Okay, 5 negative 9 multiplied to 1 is negative 9. 5 minus 9 will give us a value of negative 4. Alright, next, 5 minus 9 multiplied to positive 2, and that is 5 minus negative 9 and 2 is negative 18, and that will give us a negative 13 value of our function f of x. Alright, so let's have our x in our inverse, that is let's try 23, 14, 5, negative 4, and negative 13. Right, so what is our inverse function? The inverse function is 5 minus x and all over 9. Alright, so at x is equal to positive 23, our inverse function becomes 5 minus 23 all over 9. Okay, so that is equal to 5 minus 23 will give us negative 18 all over 9. That is equal to negative 2. Right. So next, 5 at x is equal to 14. That is 5 minus 14 all over 9. That is 5 minus 14 will give us a value of 9. Negative 9. And divided by positive 9 will give us a value of negative 1. And then next, 5 at 5. At x is equal to 5. 5 minus 5 all over 9. That is 5 minus 5 is 0. All over 9 will give us a value of 0. And then at x is equal to negative 4, our inverse is 5 minus negative 4 all over 9, and that is 5 minus negative 4 will give us positive 9 all over 9. That is equal to positive 1. Alright. Next, at x is equal to negative 13, our inverse function is 5 minus negative 13, that is all over 9. 5 minus negative 13 will give us 23, positive 23. 18. Okay, 18 all over 9, and that is 18 divided by 9 is 2. Alright, so that is the table of values of our two functions. Okay, so let's have its graph on one Cartesian plane. So let's graph the table of values that we have. So let's graph first what is our function, that is negative 2 and 23. Negative 2 and 23. So approximately nandyan. Okay. And then negative 1 and 14. Negative 1 and 14. And dito approximate mo nandyan. Ayan. And then 0 and 5. And then 1 and negative 4. And then 2 and 13. And so let us connect the dots and assume that that is a straight line. So that is our function, our function f of x. Alright, let's have our inverse function. I will mark it green. So 23, positive 23. So dito siya. 23 and negative 2. Negative 2. Approximately, and negative 2 dito. Ayan. And then 14 and negative 1. 14 and negative 1. And then 0 and 5 and 0. And 0. And then negative 4 and 1. And then negative 13 and 2. So let's connect the dot. Assume that this is a straight line. Okay. So that is our inverse function. That is the graph of our inverse function. Alright. So remember this. A function f is a one-to-one if no two elements in the domain of f corresponds to the same element in the range of f. This means that its x values must be matched to one and only one y value. Algebraically, if f of x sub 1 is equal to f of x sub 2 implies x sub 1 is equal to x sub 2, then f is a one-to-one. Remember, a horizontal line test, a function is a one-to-one if each horizontal line does not intersect the graph at more than one point. Remember this. Let f be a one-to-one with a domain A and range B. Then, the inverse of f, denoted as f inverse, is a function with a domain B and a range A, defined by f inverse of y is equal to x, if and only if f of x is equal to y for any y in B. To solve the inverse of the one-to-one function, there are 3 steps. First is to write the function in the form of y is equal to f of x. Second, interchange x and y variables. Third, solve for y in terms of x. The resulting equation is the inverse of x. If f is a one-to-one function consisting of ordered pairs x and y of real numbers, then the inverse of f is the set of the inverse functions equal to the set of y and x, such as x and y is an element of the function. The inverse function is also one-to-one function and its inverse is the function. The domain of the inverse function is the range of the function, and the range of the inverse function is a domain of the function. And the graph of a function and the inverse of the function are symmetric with respect of the line y is equal to x. If you have a question or clarification in our video lesson, don't hesitate me to message in my messenger account, that is Kim Francis Season Alum. Thanks for watching, and I hope that you learned something in our video lesson for the day. Please like and subscribe in my YouTube channel for further video lessons that we will have. Thank you. Bye.